Hi all, this is Miss Rosita, and we are continuing our discussion on inverse trig functions from section 7. So last time we were reviewing just generally what an inverse is, both algebraically and graphically. So algebraically switching x and y, graphically reflecting across the line y equals x. We had moved on, we looked at inverse trig functions, so looking at a sine wave, restricting its domain to the portion that would pass a horizontal line test, and then flipping it across the line y equals x to get our inverse sine function. We did the same thing for the cosine and the tangent. Remember, cosine, your interval is 0 to pi, restricted domain, and tangent is negative pi over 2 to pi over 2, not inclusive. And then I had said that even though you might see a couple of these on your homework, you wouldn't be given a graph of secant, cosecant, or cotangent on the test. But I think maybe I put one in the homework. I can't remember. Okay. So then we looked at algebraically, or I should say analytically, inverse trig functions, and also with the picture. And here we are now talking about composite functions. So for starters, if you look at the equation on the left, we have arc cosine of 7 pi over 2. So this is a composite function. We have the inside function as cosine of 7 pi over 2. The outside function would be arc cosine of this value. So to evaluate it, in the directions I forgot to type at the top there, it would just say evaluate. So cosine of 7 pi over 2, I'd have to figure out where is 7 pi over 2 on the unit circle and what is that point's x coordinate since we're looking for cosine. Cosine's x. So 7 pi over 2, if you count out, the top of the circle is 1 pi over 2, and then you have pi, then 3 pi over 2, 4 pi over 2. Just keep going around. 7 pi over 2 is at the very bottom of the unit circle. So if it's at the very bottom, the cosine is 0. So I went ahead and plugged in 0 for that. Then I asked myself, I want the angle whose cosine is 0. So I'm thinking, where on my unit circle is cosine 0? Well, again, it's going to be the bottom of the unit circle where we had seen 7 pi over 2, but also at the top of the unit circle at pi over 2. So since there's two locations where the cosine is 0, I have to make sure I'm giving the answer in the interval that our cosine is restricted to. So looking at cosine's restricted domain, we said that that was going to be, well, here, I'll just back up. So I'm looking at this top one. We said cosine was 0 to pi. So remember here in the middle picture, our cosine curve in green, it ran from 0 to pi. That was going to be our restricted domain. So in terms of our unit circle, 0 to pi is the top half of our unit circle. So I can't give the bottom point on my unit circle as an answer. I have to pick pi over 2 at the top. Okay, the other example, I have tangent of arctangent of 25, and it says it just equals 25. Well, if you think about it, tangent and arctangent are inverse functions. They should just cancel out and give you your original value back. So that's always going to work. But you might be kind of looking at that first example thinking, wait, this was arc cosine and cosine. Those are inverse functions, and it didn't give me 7 pi over 2 in the end. It only gave me pi over 2. There's a difference here. So if your inside function is the arc trig function, then yes, it's just as simple as saying whatever that middle number is, original number is what you get in the end. But if the arc function is the outer function, not the inner function, then there's a chance that no, you're not going to get the exact same value back because your answer is what the arc cosine of that is, and the arc cosine value always has to be in that interval that's in our restricted domain. So if the original problem happened to have said arc cosine of pi over 2, yes, my answer is pi over 2. But if it says arc cosine 7 pi over 2, well, 7 pi over 2 is not in our restricted domain, so I can't give 7 pi over 2 as my answer. So I just have to be careful on that, on those questions where the arc is on the outer function, not the inner function. Okay, so moving up in level of difficulty, let's say our trig functions are not inverses. We have sine, and then we have arc cosine. So for starters, we still look at the inside function. Excuse me. The inside function is arc cosine of root 2 over 2. So remember, an arc of whatever trig function always represents an angle. So over here on the right, then I was picturing theta as being arc cosine of root 5 over 5, just some angle. So I could rewrite that if it's helpful to think of it this way, that cosine of some angle is root 5 over 5, and I'm trying to figure out what the angle is. So again, if I go to my unit circle, I'm thinking to myself, where is the cosine positive? Which quadrants? Well, cosine are x values, so x is positive in quadrant 1 and quadrant 4. However, the restricted domain for cosine is 0 to pi. So if I have to be on the upper half of my unit circle from 0 to pi, then I've got to pick quadrant 1 because quadrant 4 is not in the restricted domain. So I go ahead and draw my angle in. Okay, central angle here near the origin, and I always connect my triangle down to the x-axis, and then I would go ahead and picture labeling the sides of my triangle. Sorry, I didn't write them in on my laptop here, but cosine is going to be adjacent over hypotenuse. So here on the bottom, you would record root 5, and then the hypotenuse, you'd record 5. So since I know two of the sides of a right triangle, I use Pythagorean theorem to get the other side, or the other leg, and it would come out root 20. So I now have all the sides labeled of my triangle. I still don't know what that central angle is. Well, believe it or not, we never are going to bother to figure out what that angle is because, looking back at our question, we're just looking for the sine of the angle. It doesn't ask us what is the angle, it just says what is the sine of the angle, arc cosine root 5 over 5. So now that I've got my picture drawn, I'm just looking for the sine of it, the y-coordinate over the hypotenuse. So I would have root 20 over 5, which I can rationalize and get my answer. Last example, a little bit harder yet because here we have a variable. Sometimes that seems to make things look a little bit more foreign, I guess, to us. But it's really not. It's the same thing. So here I'm looking for an angle whose tangent is negative 3x. Tangent is negative in quadrants 2 and 4. But the tangent inverse, we are restricting our domain to be from minus pi over 2 to pi over 2, the right half of our unit circle. So that means we have to go with quadrant 4 where tangent is negative and it's in our restricted domain. So once again, I draw in my angle, always connect to the x-axis, and I label the sides of my triangle. So since tangent is y over x, the y side I would call minus 3x, and the x side I would call 1. Y over x minus 3x over 1. And then I can do my Pythagorean theorem to get the hypotenuse. So 1 squared plus negative 3x squared is going to be, and then square root would be root 1 plus 9x squared. And then again, I'm looking for the secant. So secant is reciprocal of cosine, so I'm looking for hypotenuse over adjacent. So hypotenuse was the square root part, and adjacent is 1. Okay. That was it. So at this point, we already did practice problem 1 in class, so now you're working on problems 2 and 3. And if you were not here when we did it, make sure you work them out anyway and check with somebody at your table group. Thanks for listening.